Welcome to The Explainer. So today we're looking at something absolutely fascinating. We're talking about the microscopic heroics that literally keep massive industrial plants standing strong. When we look at colossal refineries, power plants, or massive chemical facilities, our eyes naturally go straight to the towering structures, right? We see these gigantic pressure vessels weighing hundreds, sometimes thousands of tons. But here's the thing. True engineering greatness isn't always about what's biggest. Actually, sometimes the absolute most critical component of an entire multi-billion-dollar project is literally less than 1 millimeter thick. No, seriously. Let's dive right into this hidden secret of heavy equipment installation.
Okay, so picture this. Imagine a Goliath-sized piece of machinery, maybe a massive industrial water pump or one of those towering chemical reactors. It rolls up to the construction site and needs to be placed on its concrete foundation. But here is the ultimate engineering puzzle. How in the world do engineers make sure this colossal beast sits absolutely perfectly level? I mean, if it's even slightly off, it'll just vibrate itself to pieces the second it's turned on. We're talking about a level of precision where literally a single 1 millimeter error could lead to total disaster. So how do we perfectly mate a really rough poured concrete foundation with an ultra-precise, highly engineered machine?
Well, the secret lies in a critical stage of groundwork that industry folks call padding. Now, you might hear different terms for site preparation on a construction project, but padding specifically is this incredibly meticulous process. It's basically placing flat steel plates onto a concrete foundation to give the equipment a flawless, elevated, perfectly level base to sit on. There's a golden rule in industrial construction. Proper preparation is like 90% of the actual work. And padding? Padding is exactly that. It's the absolutely crucial bridge between the rough, messy world of pouring concrete and the ultra-precise world of mechanical engineering.
Now, the real marvel here is the material itself. Just take a look at these Shim plates. Honestly, they are the tiny Davids of our heavy industry story. They're millimeter thin, and sometimes we're even talking fractions of a millimeter thick. Because they have to shoulder the crushing weight of literally hundreds of tons, sitting outdoors for decades without degrading, they are made out of ultra-high-grade stainless steel. Think about it. If they rust or corrode even a tiny bit, the whole machine tilts. So these incredibly thin, super tough little plates are carefully stacked, almost like a highly calibrated deck of metal cards, to create the exact perfect elevation.
This right here brilliantly shows the whole transformation process. We start off with a pretty stark concrete foundation on the left. Now, before any padding happens, engineers have to do something called chipping. They intentionally smash and break away the smooth top layer of the concrete. Why? Well, that very top layer is actually kind of weak, so they need to expose the rough, strong, rocky aggregate underneath to get a much better grip. But obviously, you can't just drop a multi-million-dollar precision machine onto a pile of sharp, uneven rocks. So through the meticulous padding process using those shim plates we just talked about, we end up with that flawless, perfectly leveled steel platform you see on the right.
If you're trying to really grasp how this works, let's just use a super simple analogy. Have you ever sat down at a restaurant, realized your table was wobbly, and fixed it by shoving a folded-up paper napkin under one of the legs? Yep, we've all been there. Well, if you've done that, you already understand the fundamental physics of padding. You're bridging an uneven floor with a filler to create stability. The only difference here is that in plant construction, we're scaling that exact same concept up to a micro-engineered industrial level. Instead of a cardboard coaster and a wobbly coffee table, we're using highly calibrated stainless steel shims to support machines that could literally crush a house.
So you might be wondering, why can't we just bolt the machines straight down onto the uneven concrete and call it a day? Well, it all comes down to load distribution. Without padding, an uneven foundation creates these massive, concentrated stress points. Imagine 500 tons resting entirely on just 2 or 3 small, pointy rocks jutting out of the concrete. The pressure right on those specific spots would be astronomical. It would cause the concrete to just crack, crumble, and fail completely. But a precisely padded base acts as this perfect intermediary. It takes that massive, crushing load and distributes it flawlessly and evenly across the entire surface.
So how exactly does the crew pull this off out in the field? Well, the procedure is an exact science. Step 1. The engineers verify the concrete foundation's exact elevation using highly advanced laser surveying equipment. Step 2, they pour a specialized, super high-strength mortar called pad grout right over that chipped concrete. Step 3, they carefully set a heavy steel pad down onto that wet grout. And then finally, step 4, and this is the most critical part, they slide in those tiny shim plates. They're adding a millimeter here, maybe taking away half a millimeter over there, just totally dialing in the absolute perfect level before the main equipment is ever even lowered into place. Okay, so here's the absolutely crucial point. What happens if a construction crew is behind schedule and decides to rush this step? Or what if the padding is just done poorly? Honestly, the results are a mechanical nightmare. The equipment simply won't sit flat, and when you turn on a massive motor or a giant turbine, that slight little imbalance, it's going to cause severe, violent equipment vibration. That vibration puts extreme stress on the massive anchor bolts trying to hold the machine down. Eventually, the internal mechanical bearings will actually shatter from the uneven load, leading to a completely catastrophic operational shutdown. We are talking about millions of dollars lost in downtime, all because a single 1mm steel plate wasn't placed right. Wild, right?
But when it's done correctly, the results are practically bulletproof. Just look at this equipment base. It is perfectly padded, perfectly leveled, resting super snugly on its customized supports, and secured incredibly tightly with those massive anchor bolts. Those tiny shim plates underneath, they are completely locked in place. At this point, they've essentially become one solid piece with the foundation itself. Because of this unbelievably meticulous groundwork, this incredibly heavy machinery is going to run smoothly, quietly, and most importantly, safely, day and night, for decades, without shaking itself apart.
It's just such a brilliant reminder that in the massive, totally awe-inspiring world of heavy industrial construction, true strength almost always relies on the absolute smallest, most meticulously placed details. You know, the giant steel towers and massive tanks, they get all the glory, but they are entirely dependent on the microscopic precision of the padding right underneath them. So I want to leave you with this final thought. The next time you drive past a giant power plant or a sprawling refinery, won't you think about the greatness of those tiny 1mm steel shim plates silently holding the whole thing up? Thanks so much for joining me for this explainer, and keep your curiosity perfectly leveled until next time.